This is going to be the spinor. It can flip this way and that way. And this is the other spinor. I'm going to label these sort of like time and space, and then space and space, and just go, so that way I've got time and 3 space, and then that gives me a vector. This is basically the photon. Super fast. I get 2 of them. They're going at the speed of light. And 2 of them together, they give us this double helix in 2 directions, a crisscrossing double helix, the quad helix. This is the gravitational waves. Big waves. There's no particle. Well, that's interesting. But they're very useful. Nothing. Well, that's just the Higgs. 0, scalar. There's just the point, just sitting there. But this is kind of the intersection of various things, yeah? So we can take... we're flipping things. This is the chirality. It's kind of like we're flipping between the tops and bottoms. Right? And we have sort of the left-handed version of the quark versus the right-handed version of the anti-particle. So, 2 spinners here, 4 spinners in total. This is kind of how we make all the fields. So this here is made with 2 spinners. And, well, we have 1 spinner, 2 spinner. But that gives us a half and a half, which makes 1. So we've got spin 1 here. So all the spin 1 fields require this. And spin 1 fields, 2 of them. This will make the spin 2 field. So we have half, 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 half. We could also make 3/2, but that's kind of interesting. If we have a triple helix, what we're doing is basically flipping between the different gluons, the colors. So you need 3 of them to make these particles. The problem is we need to make fermions. So how do we do that? So let's take 1 and 1. We need another one, sort of a 3rd dimension sticking out here. So we're going to rotate. There's 3 of them, but I need to get that intersection going. It's kind of hard. But let's go 1, 2, and 3. And in the middle, we have one of these fermions. It's at the intersection of 3 single helix strands. Now the second requires 2 double helix and then just a 1. The single strand is helpful because we can twist things. And then we have the double helix again here. So we have 3 of them coming together. So that way we can flip things around. And then we always have to connect it with the single strand because the single strand just gives us a lot of mobility. Let's go to the 3rd. So it's always a triple and a triple coming together with a single that can spin it around. At the center, we have the particle, the fermions. We need to cancel all the anomalies. So we have to take the quad helix and stick them together too. And do the same thing, but the more gives us just closure rules for all these charges. Because we have to sum up all these charges, so that just fixes the charges. Gravitational waves. Gravitational waves are super weak. They dissipate pretty quickly, so... But that's the thing, these gravitational waves are made by these quad helixes, like this quad helix is just crisscrossing in the middle, and they twist around like this. These things are big, but they sort of break apart. And they sort of make these spin 1 fields, and they kind of just all dissipate to make the Higgs. So you kind of got spin 2, spin 1 and spin 1, and then spin 0, or Sometimes we really need that spin one half come together to make that spin a half, spin a half. So now if you got a triple helix, you can kind of do those glue-on things where you're flipping between the colors. Yeah, this is crazy, but you know, standard model of particle physics all pops out when you use helixes.